Hi everyone, welcome to the mathematical perception. In this video, I am going to explain you a problem from CSIR NET 2022 exam, and the problem is coming from the number theory portion. So in the last video, I explained you one problem from International Mathematical Olympiad. This time we have CSIR NET problem. So let's have a look at the problem. Problem says that we have the function fn defined as n raised to 5 minus 2n cube plus n, where n belongs to n. Then we are asked about the function fn, and options are: for every k belongs to n, there exists n belongs to n such that 2 raised to k divides fn. Second option is fn is even for every n greater than or equals to 20. Third option is for every n greater than or equals to 20, either fn is odd or divisible by 4. And the last option is for every odd integer n greater than or equals to 21, fn is divisible by 64. This is MSQ type problem, so multiple options can be correct. So let's have look at the solution. First option, we have fn equals to n raised to 5 minus 2n cube plus n. It is given that we can modify it a little and it will become, and this will also become n square minus 1 whole square, right? We know the identity a minus b whole square. So eventually we will have fn equals to n times n square minus 1 whole square, right? What can you say about this modified function? First option is that for every k there should exist a n such that 2 raised to k is divides fn, right? So if k raised to n is given, what we can do, we can choose n इक्वल्स टू 2 रेज टू के, है ना? हमको क्या चाहिए? फॉर एवरी के हमको एक ऐसा नेचुरल नंबर n चाहिए सच दैट 2 रेज टू के fn को डिवाइड करते हैं. हमने क्या किया? हमें एक k दिया था, हमने n इक्वल्स टू 2 रेज टू k चूज कर लिया. नाउ इफ वी पुट दैट, देन fn कैन बिकम 2 रेज टू k टाइम्स 2 रेज टू 2k minus 1 whole square, right? By the definition of the function, clearly it is visible that 2 raised to k divide fn. And now since k is arbitrary, k is a random integer we picked, so for every k there exists n which will be given by 2 raised to k such that 2 raised to k divide fn. So option 1 is correct. Alright, let's have a look at option second. What is option second? fn is even for every n greater than or equals to 20. So there are only two possibilities for n. Either it can be odd or it can be even. So let's have case 1. What is case 1? N is even. How can n is even? N can be even, then fn should be even. Can you see that? Why? Because n is already a factor of fn, right? So if fn equals to n times n square minus 1 whole square, now if 2 divides n, since n is even, so 2 divide n, and since 2 divide n, it implies that 2 also divide fn, right? You can say by division lemma or by using like since 2 divides right hand side, so it should also divide left hand side, basic thing, right? And if 2 divides a number, then the number is even, so in this case fn is even. So in the case when n is even, fn is also even. What is the case 2? N is odd. When can n be odd? So for n to be odd, we know that any odd integer can be written as this form, right? Because of the division lemma, you can say that any odd integer leave remainder 1 when divisible by 2. So it can be written in this form 2m plus 1 for some natural numbers m. So n equals to 2m plus 1. If you put that in the equation, we will get n equals to 2m plus 1 times 2m plus 1 raised to 2 minus 1 and whole square, and eventually it will become 2m plus 1 times 4m square plus 4m whole square. Alright, and we can modify it a little and we can take 16 common, and then it will become 2m plus 1 times m square plus m whole square. Alright, clearly left hand side is divisible by right hand side is divisible by 2, so left hand side is also divisible by 2. It implies 2 divides fn because 2 also divides 16 times 2m plus 1 times m square plus m whole square. Alright, so we covered both the cases, when n is even and when n is odd. In both cases we got fn is also even, hence fn is even for all n greater than equals to 20. This is also correct because fn is even for every natural number, so it should be even for every natural number greater than equals to 20 also, right? So option second is also correct. Now for the third option, I will not explain it, do it by yourself. I will just give a hint, okay, because some work you should do by yourself also. So I am giving a count example. If you pick n equals to 22, then if 22 is even but not divisible by 4, it is a very easy exercise to verify. So you can verify that f22 is even but it is not divisible by 4, and hence option first is correct, second is correct, but option third is incorrect. Moving on to the last option, fourth. So when I was explaining fn is the second option, there we got when n was odd we pick 2m plus 1, n equals to 2m plus 1, and for that n we got fn barabar 16 times 2m plus 1 times m square plus m whole square, right? So in this case also we were asked for every odd integer n greater than equals to 21, fn is divisible by 64. From the formula in equation 1, it is very clearly 16 divides fn, right? 16 divides fn. How you will create one more factor? Can you see that 64 can also divide fn? Here's the trick. What is the trick? Consider m square plus m. It can be written as m times m plus 1. And you have to prove that m square plus m is always divisible by 2. So 2 always divide m times m plus 1. Why? Can you give the reasoning? Reasoning is very simple. If m is odd, then m plus 1 is even. Hence m times m plus 1 is even, right? And if m is even, then clearly m times m plus 1 is also even. So whatever m you pick, m times m plus 1 is coming even. So m times m plus 1 is always divisible by 2. What does that mean? It means that since 2 divide m square plus m, it implies that 2 square should divide m square plus m, right? Because of the properties of properties of prime numbers, you can say, if 2 divides m square plus 1, then 2 square also divide m square plus 1 whole square. So it implies that 4 should divide m square plus m whole square. What does that mean? This means that m square plus m whole square can be written as 4 times say some number q. Some q belongs to natural numbers, right? If 4 divides m square plus m whole square, it means that m square plus m whole square can be written as some number which is the multiple of 4. So it can be written as 4 times q, right? So substituting this in equation 1, putting second in 1, what we got? Fn equals to 16 times 2m plus 1 times 4q and this implies 64 divides Fn if n is not. And not even for n greater than equals to 21, it is always true. For any odd you pick, any odd number you pick which is not actually not 1, for every odd number which is more than 1, you can say, it is always divisible by. Even for 1 it will be giving 0, so 0 is a triple case. So leaving that, for any odd number you pick, 64 will always divide Fn. Hence 64 will always divide Fn if that number is greater than or equals to 21. So what you can write? If n is odd and if n is greater than or equals to 21 also. Okay, so option 4th is also correct in this way. What we use, the simple technique we used is because natural numbers are, or every integer is follow the unique factorization property, unique factorization into primes, and hence if 2 divide m square plus 1, so 2 square also divide m square plus m whole square, and then we moved on to the equation Fn equals to 64 times 2m plus 1 plus q, and hence 64 divides Fn. That's it for today. See you soon.